Today we have a really weird problem with plenty of tricks to go along the way. A boat is sailing up and down a 240-meter river with a current. There we go. 240 meters long. When riding with the current, the boat moves at a speed of 11 meters per second. So we'll call the boat's speed, and we'll call that B. And we also need to know the current speed. We'll call that C. And we know B plus C equals 11, because when it's riding with the current, so it's moving faster. If the time it takes the boat to travel across a 240-meter river with no current is 50 seconds faster than a boat traveling at the current speed, how fast would the boat travel against the current? That was a lot of information, so let's see if we can break it down. You see, this part is the question: how fast would the boat travel against the current? In other words, B minus C. This is what we need to find at the end. So we hope to get another equation with B and C so that we can figure both those out. The time it takes the boat to travel across a 240 meter with no current. So this part right here, time it takes with no current. We need to use the idea that time equals distance divided by speed. And how do I know this? Well, we know that speed is written in meters per second. Speed, meters per second. Meters is distance, and seconds is time. So we have S equals D over T. I move the T, and I move the S equals D over S. And as we can see, T equals D over S. So we have 240 meters divided by boat speed with no current is just B. And we see this is 50 seconds faster. So this is smaller than the number that comes after. So we must add the number to make it bigger. And the bigger number is 240 divided by the current speed, or C. Now we have here a system of equations which we can use to solve B and C. We'll do that by rearranging this. We see that B equals 11 minus C. And so we'll go ahead and substitute that in. 240 divided by 11 minus C plus 50 equals 240 divided by C. What we're going to do is we're going to multiply both sides, multiply by C times 11 minus C. Notice these are denominators, and that way we can clear them out. This 11 minus C cancels with this 11 minus C, so we have 240C. This 50 cancels with neither, so we have 50C, 11 minus C. This C cancels with this C, so then we have 240, 11 minus C. Clean this up a bit, 240C plus 50C times 11, that's 550C. 50C times negative C, it's negative C squared. 240 times 11, there's a trick when you multiply by 11. This is 24 times 11. So we do 24, and then the sum is 6, so we stick that in the middle. And this is 240, there's a 0 here. And we have minus 240C. Let's clean this up a bit. C squared, we have 240, and we'll have minus 240 and minus 550. So this side is going to be minus 790. So this is minus 1030C. I forgot this is 50C times negative C. This should be 50C squared. And this 2640 remains. So we have a quadratic equation. I'm actually going to divide by 10. Get rid of these zeros here. So we have the quadratic equation 5C squared minus 103C plus 264 equals 0. This looks like a prime target for the quadratic formula. C equals negative B, it's 103, plus or minus the square root of B squared, 103 squared, minus 4 times A times C, all over 2A. 2 times 5 is 10. This is incredibly messy, but let's go over some tricks real quick. So 103 times 103. 3 times 3 is 9. 3 times 0 is 0. 3 times 1 is 3. 0 times anything is 0. So this is just zeros. And then 1 times 103 will stay 103. We get 9, 0, 6, 0, 1. Okay, we need 4 times 5 times 264. This part is 20, so we really have 264 times 20. Now when you multiply something with a 0 on the end, I like to temporarily ignore it and treat it like it's 264 times 2. 528. Then stick that 0 at the end. 5280. We have 10,609 minus 5280. We can see that that is 5,329. Cleaned up those calculations a bit. So now we must find the square root of 5329. We see that 70 squared. 7 times 7 is 49. There's 2 zeros. 80 squared is 8 times 8 is 64. It's in between there. It ends in a 9, and we know 3 squared is 9, so we can try 73 squared. 3 times 3 is 9, 7 times 3 is 21, that's 21 again, and 7 times 7 is 49, plus 2 is 51. And we see indeed that it is 5329. So this equals 73. Okay, which means we have 103 plus or minus 73 over 10. That's going to be either 186 over 10 or 30 over 10. This is 18.6 and this is 3. Now if it was 18.6, B has to be negative, and you can't really have a negative speed, so this is not valid. So C must be 3. And if B plus C equals 11, and C is 3, then B must be 8. So our final answer, B minus C, equals 5. 5 meters per second. This was a very, very complicated problem with a lot of steps, but it has some ideas that you will see common. Like, for example, this current problem is something you might see several times, and it's important to make sure you organize your information, get your equations properly set up, and then do your math. There was also some tricks with quadratic formula here. We saw that because it ended in a 9, I tried 73 squared first, and that turned out to be useful. But if not, you'll have to adjust up and down, depending on if it's a little bit bigger or a little bit smaller, to get as close as you can.